Hello everyone, in today's video we'll be going through some IB exam style questions regarding to polynomials and their complex roots. So in this first question, we're being asked to find the cubic function with real coefficients which has roots x equals 2 plus I and x equals negative 3. And the coefficient of x to the power 3 is equal to 1. Write your answer in expanded form. Alright, so first of all, let's go ahead and write the function. F of x, this is what we're aiming to look for at least. Ax cubed plus bx squared plus cx plus d. Okay, so we are trying to find the real coefficients, right? These are just letters that I labeled just to see an idea of how it should look. And it's given that the coefficient of x cubed is equal to 1. So we can say that a is equal to 1, right? And we're given the roots, which is x1 is equal to 2 plus I, and x2 is equal to negative 3. But we also need the third root to completely, to completely write it in the factor form and then expand it. However, we don't know it. But we do know that, and it works for all the cases, if a polynomial has a complex root a plus bi, let's just say, then its conjugate a minus bi is also a root of that polynomial. Okay, so we have to note this down. This is a really important thing that will help us to further solve these polynomial questions. So if if 2 plus I is a root of the polynomial, then we can say that the third root will be 2 minus I, its conjugate, okay? And conjugate means this, okay? So if z, real number for which z is an imaginary number, okay? If z equals to a plus bi, then z conjugate with z star is equal to a minus bi. Okay, we have to note this down. Okay, we cannot forget about this. So after finding out the roots of this function, we can go ahead and write this, right? Because to write a function in a factor form, we have to write something like this. A, which is the leading coefficient, x minus x1, x minus x2, x minus x3, and goes on, x minus xn. Now this n depends on how many roots a polynomial has. In this case, the polynomial is to the power of 3, so we're working with a x to the power of 3 polynomial. If it means the degree is 3, then it has to have 3 solutions. No matter what, it has to have 3 solutions. So then we have to write it in this form, okay? If the function was a quartic function, then it would be x minus x1, x minus x2, x minus x3, and x minus x4. However, we are working with a cubic function, so it has to be only 3 brackets right over here, 3 factors, okay? So, and a is given, a is the leading term, okay, leading coefficient, sorry for the term, but is coefficient, okay? In this case, the leading coefficient is equal to 1. So whenever you write, make sure you write the leading coefficient, okay? The leading coefficient must always be outside of the brackets, being multiplied to 2. So we can write that 1 x minus x1 is 2 plus I. So we have to write this in brackets, by the way, 2 plus I, okay? Because we're minusing the whole thing. X minus x minus 3, so it's going to be x minus 3. The second root is that, and the third root is x minus 2 minus I, x minus 2 minus, oops, just a minor mistake right over here, x 2 minus I, okay, 2 minus I, okay. Now let's go ahead and expand this. It should look something like this: x minus 2 minus I, x plus 3, x minus 2 plus I, okay. And then we see this, right? We see this, right? So just write them together next to each other: x minus 2 minus I, and x minus 2 plus I, x plus 3. Okay, so this thing is actually similar to the formula of a squared minus b squared is equal to a plus b, a minus b, right? In this case, a would be x minus 2 and b would be I. So we can say that this is x minus 2 squared, x minus 2 squared minus I squared, okay? So just a second. All right, so we can say that this is x squared, and we have to multiply this by what? By x plus 3. We can't forget about this. X squared minus 4x plus 4, okay? So I squared is -1, so it's going to be plus 1. And we have this multiplied by x plus 3, okay? So x squared minus 4x plus 5 multiplied by x plus 3. So then this would be x cubed plus 3x squared plus 3x squared minus 4x squared minus 12x plus 5x plus 15. Okay, so eventually we would get this x cubed plus, x cubed minus x squared, yes, and minus 12x plus 5 would make plus negative 7x, okay, and plus 15. So this, ladies and gentlemen, is our final f of x. Okay, this is our final function, and we found the answer to this. So this question worth 4 mark, we have just completed it. So that's simple. Okay, now let's go to question number 5. Let f of x be x cubed plus bx squared plus x plus 3. When f of x is divided by x minus 3, the remainder is 3 times the remainder when divided by x minus 2. Find the value of b. Okay, now we know that if this is our divisor, this is 2, we know that f of 3 would be the remainder, right? So let's see. So 3 cubed was 27 plus 3 squared times 9 times b, which is 9b plus 3 plus 3. Okay, that gives us what? 6 plus 27, 33 plus 9b is our remainder. Okay. Now it says when the f of x is divided by this, let's find the remainder then. So it's going to be 2. F of 2 will be our remainder 2. Okay, this second remainder when we divide it by something different. Okay. So this is 2 cubed, which is 8 plus 4b plus 2 plus 3, which is 5 plus 8, which is 13. So 13 plus 4b. Okay, this is our remainder 2. Okay. So now it says that when f of x is divided by x minus 3, in this case, the remainder is 3 times bigger the remainder when divided by x minus 2. So that means that this remainder, 3 times r2, is equal to r1. Our r1 is this, okay? Our r2 is this. Let me just write this like that, okay? So 3 times 13 plus 4b equals to 33 plus 9b. So 3 times 13 is 39 plus 12b equals to 33 plus 9b. And this makes, if we put that to that side, we're gonna get what, 6 if we bring minus here. 6 equals 9b minus 12b. So 6 equals to negative 3b. Okay, and so b is equals to negative 2. Okay, we just divided by negative 3 both sides. Okay, so we have negative 2 as our answer. So yeah, we found it. Okay, question number 7. When the polynomial x cubed plus ax squared plus x minus 1 is divided by x plus a, the remainder is equal to 1. Find the value of a. All right, for this one we have to use the remainder theorem. Okay, so if our divisor, this is our d of x, so the 0 of our divisor, if we put it into our polynomial and replace x with it, we should be able to get our remainder. Okay, so our f of x is x cubed plus ax squared plus x minus 1, and our d of x is x plus a. So if we say x plus a is equal to 0, then x would be equal to negative a. Okay, and then we can say that f of negative a should give us the remainder, which is remainder. And actually the remainder is equal to 1, so we can just erase this real quick and write 1 because the remainder is 1, equal to negative a cubed plus a times negative a squared plus a minus 1. And we get here negative a cubed plus a squared times a, which is a cubed, plus a minus 1 is equal to 1. Negative a cubed and a cubed cancels out, so a minus 1 is equal to 1, and a is equal to 2. That's it. We found a.